Welcome to the Unit 6 Day 3 notes. For this warm-up problem, before you pause the video, I want to make sure you know what I'm expecting. It says sketch the graph of the following translations of triangle ABC and show both translations. So you need to sketch triangle ABC. You are going to get triangle A prime, B prime, C prime. Draw that as well. And then you are going to have to move it again to get triangle A double prime, B double prime, C double prime. So you're going to have three triangles drawn. You're going to have A prime, A double prime, same with the B's and the C's. Okay, I wrote the translation out a little bit different using our coordinate notation. This is where we start, A prime, A double prime. So go ahead, pause the video and work this out. When you're done, unpause and see how you did. So I'm going to do the first triangle in red. 2, 1 is right there. 4, 3, and then 8, 2. So this is A, B, C. All right, so A is at 2, 1. That goes to A prime, which is going to be at 2 minus 2, 1 plus 5, which is 0, 6. Okay, I'm going to get these 3 points for A prime, B prime, C prime, then I'm going to graph them. Okay, I'm going to do this in a different color though. So B was at 4, 3. That's going to go to B prime at 4 minus 2, 3 plus 5, which is going to be B prime is 2, 8. And then C, which was 8, 2, is going to go to C prime, 8 minus 2, 2 plus 5 is 6, 7. So I'm going to graph A prime, B prime, C prime in green. So 0, 6 is A prime, 2, 8 is B prime, and then 6, 7 is C prime. So right now, if you did the distance formula, AB is the same length as A prime, B prime, same with AC and A prime, C prime, etc. So now in blue, I'm going to do that final translation. I've already done these two. Okay, I started here and went to there. So to get this next point, A prime was 0, 6. That's going to A double prime, 0 minus 6, 6 minus 3, which is negative 6, 3. B prime was 2, 8. That's going to be double prime, which is 2 minus 6, 8 minus 3, or negative 4, positive 5. And then C prime was 6, 7. It's going to C double prime, 6 minus 6, 7 minus 3, which is 0, 4. So in blue, I have negative 6, positive 3 for A double prime, negative 4, positive 5 for B double prime, and 0, 4 for C double prime. All right, those are what all three things should look like. Notice that I have A, B, C, A prime, B prime, C prime, A double prime, B double prime, and C double prime. If you don't put those primes, you are then saying it is a different point, which is incorrect. So make sure that you are clearly communicating which value you are graphing. All right. So today we're going to talk about reflection rules. So when we are reflecting, we are always reflecting. They'll say in a line. That just means across a line. So if I'm reflecting in the x-axis, okay, remember the x-axis is going to be this one going horizontally, right? So if I'm reflecting across, I'll use a different color. If I'm reflecting across this line, I go to the other side. My x value did not change, so my A value is still A. My B value went from being B above the x-axis to now B below, so that'd be negative B. If I had started here and had a negative B, then it would become a positive B. So that negative B just means the opposite of whatever that y value was. Okay, it's very similar for going across the y-axis. Okay, the y-axis is the up and down one. So if I have a point there, If I'm reflecting in the y-axis, I'm going across this side. So I'm going to have negative a, or opposite of a, comma b. You are changing which side from positive to negative that x value is. So the first one, reflecting in the x-axis, just means reflecting across the x-axis. X value doesn't change. Your y value is changing between positive or negative. If I'm reflecting in the y-axis, just across the vertical y-axis, then my x value is going from positive to negative, or negative to positive, and the y value does not change. Where you're going to have a little bit of difference is if we are reflecting across the line y equals x. So the line y equals x is going to look like that blue thing. If I have a point here, reflecting across is going to go over there. You are changing your x and y around. You're flipping them. All right. The next one is the one that's the trickiest. All right. I'm going to draw this one a little bit bigger. So the line y equals negative x is going to go, that was off, it's going to go right there. All right. The reason why this one's going to be the trickiest is because of your negative signs. All right, this is going to go to negative b, negative a. You're still flipping your x and your y around, but this negative b, negative a portion. All right. Right here, this is going to be a negative x value. It's going to also be a negative x value over here. Okay. I'll use green. From here to here, this is a negative x value to a positive x value. So it's going to kind of depend. This rule is one where I don't really like to think of it as much as just count it out. And I'll show you how to count it out in a little bit. Just because where these things come up changes things. If I flip across, my x is negative here for both of those red ones, and it's positive for both of these blue ones, but it goes between negative and positive for those green ones. So it kind of depends. So I don't really like this rule so much. This rule up here, that one's perfectly fine. You still have an issue sometimes in those opposite quadrants, but like I said, I'll show you a very, very easy way to do these reflections in just a second. All right, so we're going to reflect point A 4 different times. I'm going to have A prime 4 different times. Normally you would only have one A prime, because then after you reflected A prime, you'd get A double prime and then A triple prime. I'm going to show each of these 4 things as if the other ones did not happen. Okay, so if I'm reflecting in the x-axis, the x-axis is I'm going to do in red. So the x-axis is right here. If I'm reflecting across that, okay, think about a mirror. The closer you are to a mirror, the closer your reflection looks. The further you are away from the mirror, the further away your reflection looks. Crossing the x-axis is really, really easy. Using that rule, that would put us at 8, negative 5 for A prime. If I just count, I go count straight to that line, I'd go down 5, so I'd go down 5 more. That's it. Okay. The x-axis, sometimes you'll see as the line y equals 0. All right. Remember that the x-axis is y equals 0, the y-axis is x equals 0. Some of us have that backwards in our heads, and it makes sense why, because we know the x-axis goes sideways, so we want it to be x equals 0. But remember, it's y equals 0 because that is how far above the x-axis it is, no matter what x equals. So in this case, our point A prime is going to be at 8, negative 5. All right. In blue, I'm going to do the reflecting in the y-axis, or across the y-axis, which is that one right there. Okay, this is sometimes, like I said, x equals 0. My A prime value, I'm going to count over. I have to count left 8. So I have to count left 8 again. That would be negative 8, positive 5. Again, I'm using this A value for the start of each of these 4 things. Those are the 2 easiest. Those used that rule just fine. Okay, my x value went from positive to negative. I'm going to do the line y equals x in green. So I'm going to sketch that line real quick. So there's the line y equals x. If I want to reflect across that line, Okay, it said change your x and your y values. So this was 8, 5, so this should go to 5, 8, according to that rule. Now here's the really easy way where you can do this without thinking about that rule. It requires you to count. All right, so what I'm going to do, I'm going to zoom in here real quick. I'm going to pick, you can count either up or over. It doesn't really matter, but I need to count from this dot to this line. So I'm going to count up 1, 2, 3. Since I counted up 3, I need to count left 1, 2, 3. It wouldn't have mattered if I had counted left 3 to begin with, because then I would just count up 1, 2, 3. What we just made is a square. All right, we made a square. Last chapter, we talked about the diagonals of a square. We know they're congruent, and we know that they are perpendicular. Okay, the reason why this counting method works is because of the fact that the diagonals are congruent and perpendicular. When we counted for A and B, if we'd used those rules, instead of using those rules, I should say, we counted straight down. Straight down is perpendicular to straight across. If we'd counted straight across to get to the blue one, that's perpendicular to straight up and down. Anytime you're finding the distance between 2 points, the shortest distance is always a straight line. I think everybody knows that. If you are finding the shortest distance between a point and a line, that straight line is still be the shortest, but it's got to be perpendicular to the line. All right? So we are counting the shortest possible route. Now, this does not mean that A prime is 3 away from A. It just means that A was 3 below this line. So A prime's got to be 3 to the left, because you are making a square. It has to be making a square or making a rectangle, I guess would be a better way of saying it, be a little bit more accurate. All right. For this next one, the line y equals negative x, I'm going to do that one in this yellowish color. Oops, got a little bit off there. There we go. So I'm going to do the same thing, okay? And I'm not even going to worry about that rule for a second. If I want to count to this line, I can go either left or down first. It does not matter. I'm going to go down first. The way I'm going to go down is this is 5 above the x-axis, I already know. So 6, 7, 8, 9, 10, 11, 12, 13. Okay, that was 13 going that way. So now I got to go 13. Well, that's 8, 9, 10, 11, 12, 13. So A prime should be at this point right there, which is negative 5, negative 8. All right, which followed that rule perfectly. Okay, it swapped the order, and it made them negative. And again, like I said before, it doesn't matter if you go left first or down first or up first or whatever, because we are making this big square. That counting method is going to make your life very, very easy on a lot of these problems. Okay, so now we want to reflect triangle ABC in the y-axis and draw the reflection. If we are reflecting in the y-axis, this just means across the y-axis, which is x equals 0. So we're going across this piece right here. Earlier I made a comment about the closer you are to a mirror, the closer your reflection looks. So I'm going to start with the thing that's closest to the mirror, which in this case is C. C is 1, 2 away from the mirror, so I need to end up on the other side. And that's going to be C prime. You are just counting over. Okay. Whatever started closest has to end up closest. No matter what happens, you are going to the opposite side of the line. Okay, so I'm going to start with C. Now I'm going to do A next because it's basically in the same area. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's A prime. B was 1, 2, 3, 4. So 1, 2, 3, 4. That's B prime. Make sure you connect your dots. And you are done. Make sure you have A prime, B prime, C prime. Just like with translations, we are showing that this is where the shape ended up after a transformation. What I didn't specify today yet was that a reflection is also an isometry or an isometric transformation, because the shape we end up with, our image, is congruent to the shape we started with, the pre-image. All right, so next up we're going to reflect quadrilateral ABCD in the line x equals 3. We didn't have this as one of our special rules. This is where counting is just going to make your life way, way easier. I already have the line x equals 3 drawn in for you, that blue dotted line. So I just need to make sure every point A, B, C, and D ends up on the opposite side or the other side of that sketched blue line. I always like to start with whatever's closest to the line. So in this case, that would be point D. So point D is one spot to the left. So point D prime would be one spot to the right of the line. C was one spot to the right. So C prime would be one spot to the left. And you can go in any order. I personally like the closest first. Doesn't actually matter. You're going to be doing the same thing for all of them. So I'm going to do A next, which is 1, 2, 3 spots to the right. So 1, 2, 3 spots to the left is where A prime is. And then B was 1, 2, 3, 4, 5 spots to the right. So we got to go 5 spots to the left to get B prime. And now something that's tricky for some people is make sure you connect the correct points. So A and B were connected. So A prime and B prime are connected. Okay, B and C, B prime, C prime, C and D, C prime, D prime, and so on. You are not going to be reconnecting any of the points we started with unless there was a magic case where the reflection didn't move, which I think we'll see in the next example or one of the examples. Otherwise, you are only connecting the things with primes. All right. I try to use a different color every time I have a new transformation, just make sure that I'm seeing and connecting things appropriately. Since you guys get to use your iPads for like everything, that might be a good habit to get into as well. So next up, we're going to reflect quadrilateral RSTU in the line y equals 6. The line is already drawn for us, and like I said, this is going to be, we're going to have a special case here. So I'm going to do red again, and I always like to start with whatever is closest. In this case, S is right on there. That means S prime is also right on there. So if you think about looking in the mirror, okay, I made a comment multiple times, multiple times now about the closer you are to the mirror, the closer your reflection looks. Further away you are, the further away your reflection looks. If you walked up to a mirror and put your nose against it, your reflection's nose would also be right on the mirror. So since this is right on the line we were reflecting across, it doesn't actually move, but I still need to give it S prime, just because of the way that the things are going to attach to S prime have changed. So I got to make sure I know that it's technically a different point. All right, so T was one spot below, so T prime is going to be one spot above. Okay, I'll go to U next. U was 4 spots below, so I'm going to go 4 spots above to get U prime. Forgot to put the prime with my T. And then R was 3 spots below, so R prime is 3 spots above. Again, make sure we're connecting S to T, S prime to T prime, T to U, T prime to U prime, and so on. Make sure you get the things connected in the correct directions. I don't want to see anything like R and T being connected because they were not connected to begin with. All right, next up is lines of symmetry. You've heard of symmetry before, and generally when people think of symmetry or if things are symmetrical, they're talking about lines of symmetry. So lines of symmetry are where you could fold a thing in half and get both sides to match up, right? Some shapes have line symmetry, some shapes don't. Some shapes have more than one line of symmetry. For example, this first one has 5. There are 5 different lines of symmetry. If I folded across this line right here, okay, that dot and that dot would fold together, and so on. But assuming these are all the same size, which doesn't say, but I'm going to tell you it is, I would also be able to fold across that line, and that line, and that one, and then I'll use that color to get that one. There are 5 different lines of symmetry there. In the next star-ish shape, there are 4 lines of symmetry. I could go right here, right there, and right there. Notice that all of these lines of symmetry are all intersecting at one common point. That's going to be kind of important. The arrow only has one possible line of symmetry, which would be right there. If you've noticed in these first three examples, when we were finding lines of symmetry, the lines of symmetry are either going to be connecting two vertices, two vertexes, so a corner to a corner. They're going to be connecting a side to a side or a corner to a side. That's pretty much it. It's the only possible way that they work. This shape right here is going to have 0 lines of symmetry. Okay, if I tried to go across side to side, well, I only have this weird down pointy section once. Don't have it up here, so that's not going to work. I don't have a nice thing in the middle here, so that's not going to work. So some shapes have line symmetry, some shapes do not. These are going to come in handy in the future. When I say these, I mean how many lines of symmetry a shape has. That's going to help you out when we start talking about rotational symmetry, which is something that you may have never heard of, but that's coming up in the future. All right. And now this next one says find point C on the x-axis so that AC and CB are as short as possible. Now, there are a few problems in your homework where this is going to be a little bit more challenging. So for this entire chapter, there are usually things that we like to use in person that it's not really feasible online. One of those is called a mirror. Okay, it's a brand name. It's basically a mirror that you can also see through. Since we can't use that, we have to make sure that we are using these grids. Some of the homework assignments just have a line, like here's a line, here's point A, here's point B, and it's the same type of question. You got to figure out on that line. In those cases, just kind of eyeball and do the best that you can. On the test, I'll make sure that you have a grid so you can get the right answers. So to do this, we are going to use reflections, if you didn't figure that out based on the fact that this video is on reflections, and I kind of said we have to use reflections. Point C has to be on that x-axis. I see students every year that I've taught this try to do something like this. That is incorrect. I am not going to be doing anything connecting A and B. What I'm going to do is reflect A prime, or reflect A to get A prime, and reflect B to get B prime. So I'm reflecting A, that was 2 spots above, so A prime is 2 spots below. That's technically enough information, but I'm going to use B and B prime to make sure that I get it like 100% right. So B was 1, 2, 3, 4, 5 above, so 1, 2, 3, 4, 5 below for B prime. What I'm going to do next is I'm going to connect A to B prime and A prime to B. Where those 2 spots cross, right here, that is where you put C. All right, so if it says find point C on the x-axis so that AC and CB are as short as possible, or some version of that sentence where we want to figure out that the length from here to there and here to there are as short as possible, you are reflecting A over, reflecting B over, connect the preimage of A to the image of B prime, the image of A prime to the preimage of B. Where they cross each other, that is where your answer is. If they cross each other and it's not on that line, not on the x-axis like it says in this problem, then you did one of the reflections, maybe both of the reflections incorrectly. Make sure you double check. All right. So your homework is on page 593. Here's a spot for you to write a summary about what we talked about in these sections of notes and any questions you may have. And I hope everybody has a great day.